Hi everyone, welcome to the Subbottom Profiling webinar. My name is Brittany Hines, Marketing Assistant here at HYPACK, and I will be your host for today's presentation. Before we begin, I just want to remind you about the chat box on the side of your screen. If you would like to chat with us or have questions, please submit them there. If you are unable to hear us or the screen goes blank, please comment in there so we can fix the issue. So for today's webinar, we are going to show you how our latest HYPACK Subbottom software simplifies the acquisition and processing of Subbottom profiling data. I would now like to introduce to you the project lead for the new Subbottom profiling software, Dr. Peter Ramsay. Peter joined the HYPACK team in January as Business Development Leader. Peter has a PhD in Marine Geophysics and is a Level 1 Certified Hydrographic Surveyor with the Australian Hydrographic Certification Panel. Peter was previously a Director at Marine Geosolutions in Australia, and he will be seeking further growth at HYPACK with our current product and advancing the company with technology outside of the company's core business. He brings extraordinary experience and expertise to our company, and we are so happy to have him here today with us to talk more about the new Subbottom software. So now I'm going to turn over the presentation to Dr. Peter Ramsay.
Thank you very much, Brittany. Just to key you into what you will learn from this webinar, I'm going to demonstrate how to interface to your Subbottom profiling system. I'll provide some demonstration and tips on acquiring high-quality Subbottom profiling data to ensure project success. I'll then also provide some additional tips on how to expertly process and interpret your Subbottom profiling data in a 2D and 3D environment using HYPACK Subbottom. In terms of an introduction to Subbottom profiling, Subbottom systems are single-channel instruments which are generally used for shallow reflection seismic profiling. Subbottom profiling systems operate at different transmit frequencies, and this has an effect on the amount of penetration into the seafloor and the corresponding resolution. High-frequency Subbottom profiling systems provide really good resolution, but they don't penetrate too far into the seabed. Low-frequency systems penetrate further into the seafloor, but have correspondingly less resolution. The interpreted data from these Subbottom profiling systems includes the thickness and qualitative sediment characteristics. Subbottom profiling systems are generally used for engineering and geotechnical site surveys, renewable energy surveys, dredging studies, mineral exploration, and habitat mapping projects. In general, Subbottom profiling systems can be divided into two types, where the energy source and the receiver are combined in the form of a transducer, or where you have a separate sound source and receiver, with the receiver generally being called a hydrophone array. How these systems work is that sound energy is transmitted into the water and is reflected from the seabed and the subsurface sediment layers. The reflected energy intensity depends on the different densities of the sediments. If you have very dense sediment, it reflects a considerable amount of acoustic energy, and this produces a dark resultant reflector on your Subbottom profiling data. If you have a look at the cartoon below, there's a survey vessel towing an entire array of Subbottom profiling systems. With HYPACK Subbottom, you can acquire and process all of these data sets. I have a few tips on installation and towing configurations for your Subbottom profiler. If you're mounting a Subbottom profiler and towing it, it's critical that the source and the array are correctly positioned to acquire noise-free data set. If you've got a vessel-mounted system, it's important that the transducers are mounted away from areas of potential noise or turbulence. If you refer to the cartoon below, you can see that we have a chirp or pinger Subbottom profiling system mounted on the port side of the vessel just adjacent to the GPS antenna. This is generally a good position as it's away from the turbulence created by the propeller and engines. With surface towed systems, it's also generally a good idea to have the sound source and the receiver array separated by the aerated propeller wash. Again, if you refer to the cartoon below, you can see that the surface towed sound source and the hydrophone are separated by the propeller wash. This is a good thing as it minimizes the direct arrival of the signal between the sound source and the hydrophone array, and that improves the data quality. If you're configuring your sub-bottom profiling system in HYPACK, the first thing you'll consider, like everything in HYPACK, is you'll start off with the geodesy and hardware setup. So first of all, you define your project geodesy. You then go to the hardware program, set up your positioning system, and then set up your sub-bottom profiler. We've got a list of supported devices, and these include single-channel analog sub-bottom profilers, simultaneous dual-channel analog sub-bottom profilers. This might be a pinger system and a sparker system being acquired at the same time. In addition to this, we support HYPACK, NMR, Geoacoustics, Knudsen, Teledyne, Benthos, specialty devices, SciQuest, etc. And we're adding to this continually. If you're interfacing to an analog sub-bottom profiling system, HYPACK recommends that you use the National Instruments NI USB 6221 digital acquisition card. We do support other National Instruments digital acquisition cards, but if you're going to do triggering internally in HYPACK, it's important that these cards support an analog output with sufficient buffering. If you're interfacing to a digital sub-bottom profiling system, HYPACK can currently control HTEC and Geoacoustic sub-bottom profiling systems, but all other systems require the manufacturer's software to control the sub-bottom profiler. For further information on sub-bottom profile acquisition, I refer you to the Sounding Better article from March 2017, where I discussed this at length. And this month, at the end of the month, there'll be another article on sub-bottom profiling processing. These can be found on the HYPACK website. HYPACK sub-bottom profiling highlights. So when we have a look at HYPACK sub-bottom, we feel that it is a very simple to use package which is feature rich. The first time that you open up HYPACK sub-bottom and you import either SegWire or JSF data into the package, you'll often notice that the data can be quite noisy. This is especially prevalent if it's boomer or sparker data. But using our signal processing systems, bandpass filtering, time-varied gain, and bottom tracking, you can produce an image like the one below, which is nice and clean and easy to interpret. And this can help you with the geological interpretation of the area. Similarly, often chirp data can have a very low signal level, like in the case below. But by the application of signal processing, time-varied gain, and bottom tracking, you can achieve a very pleasing result like the one that you can see in the image. Notice that I haven't employed any bandpass filtering here, as HYPACK generally recommends that you don't bandpass filter chirp data except if there's a lot of vessel noise. One thing that you can also do to the data is apply various color palettes to it. And here we've actually colorized the sub-bottom profiling data to accentuate some of the geological strata that are visible. In terms of data interpretation, HYPACK supports the digitizing of reflectors and the digitizing of targets within the sub-bottom profiling data. In terms of reflector digitizing, we support the digitizing of up to 20 individual reflectors, which can be assigned custom names and custom colors. What one can also do is colorize the various geological horizons according to their characteristics. And currently we support the colorizing of 3 individual HYPACK polygons. In the 3D environment, you can create fence diagrams from your sub-bottom profiling data. And here we have 2 lines which actually intersect each other at 90 degrees. And you can actually go and fly through this data in 3 dimensions and view the sub-bottom information. You can also superimpose your interpretation on the fence diagrams, as you can see in the image below. There's 3 separate sub-bottom profiling lines with superimposed interpretation, and we've actually put scale bars around the edges to give you an idea of the dimensions.
Thank you, Peter. So now we're going to move on, and Peter is going to show us how you set up hardware for Subbottom and how to acquire data.
Thanks very much, Brittany. So this is the typical HYPACK shell that you see loaded up, And again, the first thing when you're starting a project is it's best to start with the geodesy, and I'm just clicking on the geodesy engine here, and I've set up the geodesy for this particular project to UTM South Zone 50. So that's simply done. The next thing you'll proceed to do is go to the hardware setup, and on my boat here, the first thing I'm going to set up is a GPS system, and I'm going to connect it to COM port 1. The next thing I'm going to set up is my sub-bottom profiling system on the vessel, and I set up the sub-bottom driver here. I go to the setup, and because this is a pinger system, it's an analog system, so I've selected the analog NI USB driver. If I've got any of the other systems here, these are the other sub-bottom profiling systems that you can actually set up. And by default, the analog NI USB will be set to channel 1 for the first sub-bottom profiler. I'm then going to go to the offsets dialog, and I'm going to set up the offsets either from the GPS or the boat reference position to the pinger transducer system. Right, because I'm towing two sub-bottom profilers at the same time, I've got one which is vessel mounted and one which has been towed behind the vessel. I'm going to set up a mobile over here, and I'm going to set up a second instance of the sub-bottom driver. And if I go to the setup dialog, again, this is a boomer system and it's analog, so I'm going to set up the analog National Instruments USB, and I'm going to allocate it to channel 2 on the card. As we're towing the boomer, we're going to get the positioning from the towfish driver. So I select the towfish DLL and I go to setup, and I can set that up to manual layback, a catenary factor of 1 because I'm towing it on the surface, and I put the A-frame offsets in, which are the offsets from the GPS position or the boat reference position to the point that I'm actually towing it at the back of the vessel. Simple as that. That is the hardware setup done. Save the changes. The next thing I do is actually plan my lines, and I've pre-planned in 3 survey lines here across this river, and then I click survey. Now survey will start up, and you'll see here in the map window there's my survey vessel, and if I just zoom in a little bit more, you can see the pinger system, which is actually hull mounted over there, and then the boomer system actually being towed behind the pinger. Now we can control the layback of that boomer system by using the towfish DLL, and I'm going to bring in the boomer a little bit closer to 10 meters behind the vessel, and I can see the change over here, and then we're going to put it out to 20 meters. Right, so that's basically the map window. We then have the data scrolling windows where the sub-bottom profiling data is being displayed. Here we have the pinger data coming in over here, and below it the boomer data. This little wrench tool will actually allow you to access a little program called the analog monitor, which allows you to be able to configure the acquisition card, voltages, and setup. If you're doing acquisition, there'll also be another icon over here, which is the base gain, where you can also get access to the card and actually boost the signal if your signal is a little bit low. You can go to the options tab here, and you can set up your depth scales, and these can be in milliseconds or meters, and you can set up your grid lines, and here the grid lines I've set up to 5 meter spacing. We then go to the sub-bottom corrections menu, and this allows you to be able to apply bandpass filtering to the signal, and because this is a pinger system, I'm probably going to want to bandpass filter it to between 2 and 8 kilohertz, as the center frequency of this particular pinger system is 4 kilohertz. I can also drag these lines over here to fine-tune the bandpass filtering if I want to get the data nice and clean. We've then got a TVG function over here, or time varied gain function, where you can increase or decrease the gain of the signal. So if you have a look at TVG1, I'm busy increasing TVG1, you can see how the record's getting a lot darker on this side. Or I can also blank TVG1 if I want to, and a little B will come up over there. TVG1 is applied through the entire data set. TVG2 is applied from the bottom tracking further down into the data. And here I've set it up to 46. Leave it like that. TVG3 is applied further down in the record to prevent acoustic burnout. And what I've done is I've set up TVG to start 8 milliseconds after the bottom tracking, and this will have a lower value. You must always set TVG3 to slightly lower than TVG2. In the bottom tracking here, I'm actually doing the bottom tracking on the Subbottom profiling data, and the red line indicates the bottom track, and the grey lines indicates the gates that I've actually set up for the bottom tracking. You can control the sensitivity of the bottom tracking. You can also control the amplitude of the data to either darken or lighten it. And you can display the data in unipolar, bipolar, rectified or colored mode. Just close that down and you can see the pinger data coming in over here. Similarly, the boomer data is actually being displayed in the scrolling data window below. And again, I have independent controls on how the data gets viewed in terms of its minimum and maximum ranges, and whether I want to display it in meters or milliseconds, and what grids I want on the data. I've then got an independent control on the Subbottom profiling corrections, where I can independently set up the bandpass filtering, the TVG, the bottom tracking, the color blur amplitude, and how I want the data displayed. Currently this data is being displayed in bipolar mode, but what I can do is I can just change that to unipolar. You can see the effect of viewing the data in unipolar over here. I can change it to rectified, which is an absolute value, or I can colorize the data if I want to. And there I've given it a nice blue-red tinge to the color. You can see the color Subbottom profiling data coming in now. So that is the acquisition of HYPACK, Subbottom in a nutshell. Let's close this down and go into processing the data sets. So again, I'm going to be processing the 3 data sets that we've acquired, and these are 3 lines across this particular river. I've also put a blanking file over here. So where you find the processing program is if you go to processing and Subbottom profile processing, and it opens up 3 windows. Now we've made the complex procedures of processing Subbottom profiling data really easy, and this is not often the case with our competitors' software. So when you initially open up HYPACK Subbottom, you'll come up with 3 windows: the processing window, the view tracks window, where you'll actually see your navigation tracks and your interpretation picks, and the settings window when you can control all of the settings on how your Subbottom profiling data will look. So let's go and load some data. If you've previously been working on a project, you can open up the previous session that you're working on, and I'm going to open up the previous session, and the previous session gets stored as an XML file called SBP XML, and this stores all of the files that you've loaded up and all of the reflector characteristics. In addition to this, your settings down here are actually stored in a configuration file called SBP config, and any of the digitizing that you've done and bottom tracking are stored in the SBP directory. If ever you manage to corrupt your Subbottom profiling project, if you merely delete the XML, the configuration file, and the SBP directory, you can start off with a clean project file again. So again, I'm just going to load up the data that I've previously had a look at, and it's loaded up the 3 survey lines. If I'm starting a project from scratch, I can go to File, New Session, load up the lines that I want to, my 3 SegWi data sets, or I can independently load in EdgeTech JSF files which have been recorded in Discover, or I can load a catalog of files. So quite a few options. Again, the first time that I load it up, I've got a choice of how I want the navigation to be displayed and applied. And if I go to File, SBP Navigation, I can choose to accept the navigation from the SegWi file itself, or if I've recorded the data in HYPACK, I can pull out the navigation from the raw HYPACK file, or if I'm using HYPACK Max, which is the full version, I can pull the raw file into Single Beam Editor. I can edit out any spikes in the navigation, save it out as an EDT file, and apply the navigation from the EDT file. But in this particular instance, I'm just going to be reading the data from the SegWi file. Right, so the next thing I'm going to do is show you how to display and zoom in the data. So what you can do is, it's opened up the data window over here. You can see the Subbottom profiling data. So I can actually page through it using these controls. I can actually use my center wheel on the mouse to move it up and down, or I can go to the zoom in X and Y direction or zoom to fit. So what I've done here is I've used the zoom to fit, so it's fitted the entire line in my screen here and the entire width of the data in my screen. If I'm brand new to Subbottom profiling, I can actually click this button here, which will automatically set your data to its maximum range. It'll apply some basic TVG and it'll bottom track the data. Only use this button if you are not familiar with Subbottom profiling data. A geophysicist will get better results than the automated results here. Right, so the next thing that you would want to do would be to apply bandpass filtering to this data set. And as this is a pinger data set with a center frequency of 4 kilohertz, you want to apply bandpass filtering in the 2 to 8 kilohertz range, which will clean up the data quite nicely. So if you just go to the frequency tab here, apply it, set the low pass range, which is 2 kilohertz, and the high pass cutoff 8 kilohertz, and then just apply that frequency filter. It's now applied it to the data set. The next tab that you'd go to is the dynamic range. This is how you view the contrast of the data, how the data is displayed, and you can also colorize the data. So when I have a look at this data set over here, I can see it's probably a little bit light. So I just want to change the dynamic range of it. So I'm going to put in a value of 20,000. You can already see an improvement in the data set. What I can also do is view the data in unipolar mode, and just let me darken it a little bit. I'll put it to 11,000. There's the data in unipolar mode, or bipolar mode if I want to. I'll go back to rectified. What I can also do is I can color the data set. First of all, what I'm going to do is I'm just going to blank the water column and just going to colorize this data set and show you what you can do. And just by playing around with the dynamic contrast, you can change how the data is actually colorized. So again, we're going to go back to just the normal grayscale, set it up to 20,000 and grayscale. Right, the next thing that we're going to do is to apply some time varied gain to this data set. Now you can apply a very simple time varied gain in terms of just an exponential one. So if we go up to the data set over here, this is the gain that's currently been applied to the data set, and you can change the value of the gain and then apply it. So there I've applied TVG gain curve, an exponential curve of 4 gain units. And you can see what the records look like. If you're not happy with that, you can also use a user-defined gain curve. What you can do is just simply click user-defined, go click on the gain curve as many points as you want to, and drag them to do a custom gain curve for this particular data set. So I'm just developing this gain curve, I apply it, and that doesn't look too bad. And if I particularly like that gain curve, I can export it and save it for later, or I can import a gain curve that I've previously set up. And now I'm importing a gain curve that I've previously worked on. So that is TVG in a nutshell. Other corrections that you can apply to the data include bottom tracking. I've already bottom tracked this particular line, but if I go to line 3, I haven't done any bottom tracking on this line yet. I'll just show you how to bottom track. The first thing you need to do is determine the length of your bank pulse. So if we go up to the signal window over here, we can see this is the bank pulse, and if we go there, we can see what the depth of the bank pulse is, and it's about 3 to 4 milliseconds. So I'm going to set this up to 4 milliseconds. I've got a couple of different algorithms that I can apply to actually do the bottom tracking, but my favorite is the first threshold after bank pulse. I then hit the estimate button. It'll estimate the threshold for the bottom tracking, and then I say calculate new seabed, and it's generated a blue line along the bottom track. I can actually do swell correction as well at this particular time, or if I'm not happy with my bottom tracking, I can manually pick the seabed in various areas to do manual bottom tracking. Now I know that there's swell in this section of the data, so I'm just going to go zoom in there and show you how to correct for that. Right, just going to that particular segment, dragging it and just zooming in a little bit. You can see that there's a bit of swell evident in this data. So if I immediately go to bottom tracking and do swell correction, it's now corrected the swell and straightened out the reflectors. But I've also noticed that there's still a little bit of noise in the water column here, which the bandpass filtering hasn't got rid of. If I just tick this box here, it says blank water column. There is my data with a nice clean water column. And again, zooming to the maximum range of the data, that's starting to look quite nice in terms of the sub-bottom profiling data. Other corrections that I can apply include sound velocity. I can set an average sound velocity value throughout the water column that I'm displaying over here. And here I've chosen a value of 1500 meters per second. And I can apply a second speed of sound value for the sediments that's applied from the bottom tracking point down throughout the record. And this generally is in the range of 1600 to 1650 meters per second. If I have a sound velocity profile, I can also load this. And there I'm actually loading up a sound velocity profile. This will be applied through the water column. Now notice that all of these corrections that you're doing are only applied when you export the data to HYPACK's all format or EDT format or an XYZ export. Other corrections that you can apply include tide corrections to the data, and again these are only applied to the exported data. They're not applied to the SegWi file. So I'm loading up a tide file. We then have this view tracks window over here, which I go to the view tracks window. This allows you to be able to see your navigation, and if I move around in the data, you can see on the view tracks a little white cross, and that tells me where I am in the data set. You can load up background charts in this. Anything that you load in HYPACK Shell will be shown up here, and what my personal favorite is to load up a multi-beam image or a side scan sonar mosaic in the background, which assists you with the interpretation. When you're interpreting the data, you'll actually see your interpretation actually come up here, and I've actually done some previous interpretation on this data, and I'm going to show you what reflector 4 looks like. So there's the digitizing I've done of reflector 4, and this is color-coded with respect to depth. So this is the depth down to that reflector. So that would be that point down to that point. That's the depth to the reflector. And the green line over there, I'll just enhance it a bit, is reflector 4. Right, you can also change the color scale here, or you can view the data as HYPACK, which is a sediment thickness. Now the sediment thickness starts off at the bottom track and goes down to the reflector. And you can see what the sediment thickness is in this area. And this view tracks window is really important for doing quality control on the data. We can do layback corrections. If you've got some third-party SegWi data that only has GPS antenna position in it, you can do a layback correction, and that will apply it to any targets that you digitize or any exported data. Latency corrections can also be performed here. Just like single beam systems, sub-bottom profiling systems can also suffer from latency effects. And in my experience, generally sub-bottom profiling latency is of the order of 0.8 to 1 second. So you can apply this over here. Right, so the next thing I'm going to do is I'm going to show you how to digitize a reflector. So what I'm going to do is zoom in this particular area and do some digitizing. I'm just going to increase the visibility of those digitizing points, and I'm going to zoom in a little bit over here and just digitize some data. So I'm going to digitize reflector 2. So I'm busy digitizing reflector 2, and if I make a mistake like that, I can easily correct it by just deleting that particular point using the shift left click, or I can move a point back to where it should be using control and left click, and I'm moving it to where it should be. If there's a break in the reflector interpretation like there, I can't see where that reflector goes. I click on the opposite side, I go end toggle, and it leaves a little gap in my interpretation. So again, I'm just going to delete those points that I've digitized. I'm going to complete my digitizing, go forward in the data. Right, so I've now digitized my reflector. and that's all been done. Another very handy tool is the annotation tool, which allows you to be able to see your reflectors and their various depths. So if I'm going over here now, I can see that the water depth is about 10.4 meters. The first sediment package is 3.6 meters thick at this particular point, and the second sediment package is about 9.7. It's a very useful tool for quality control work. You can also add targets into your data, and I might want to put a target if I saw a pipeline or something like that, and I merely just right-click, add the target, and the target is visible there. I can also edit the target by moving it around. If I'm not happy with the position, I'll just move the target to another position and save it, or I can actually delete the target if I want to. What I can also do is I can colorize the sub-bottom profiling data to its individual geological characteristics, and I merely do this by clicking this button and setting up how I want to colorize the data, the actual color, and the level of transparency. Right, so the next thing I'd like to show you is how to view this data in 3 dimensions in a fence diagram. So I have my 3 lines of data over here that I've interpreted, and I'm going to generate a fence diagram from these. So I merely go to File, Export Fence, All Lines, and it will very quickly generate the fence diagram of the data sets. And there is the fence diagram. I can decide whether I want to make the water column transparent or actually leave the water column in. Here's the water column over there, or I can just make it transparent, and I just hit the reload data. So I'm having a look at my fence diagram now, and by using the shift left click, I can move around in the data set. I can use my mouse wheel to zoom in, and I can pan around in the data set if I want to. Very, very useful tool. If I've done any interpretations, I can add this as well, and I'm just going to add in the interpretation that I've currently done. I'm going to make the lines fairly thick so you can see them, and there is my interpretation superimposed on the data set over there. If I've generated any of the color HYPACK fills, I can actually just click on that, go back to the fence diagram, reload it, and there is my interpretation, and I can view this data in 3 dimensions, zoom around in it. Very, very powerful tool. What I can also do is I can actually crop the data to a particular border file. I've got this border file over here. Maybe I'm only interested in the data in this particular area. So I go and load my border file, and I want to trim my SegWide data to this border file. So I just simply click that. Automatically reprocesses the SegWide data and will only show me the data that is included in that border file. What I can also do is I can trim the data to the border file for the fence diagram, and I'll do this just very quickly, regenerating all the data for the border file that's cropped to the border file and displaying it in 3 dimensions in the fence diagram. And you can see how quickly I actually did that. Right, the last thing that you want to do is export your data sets. Now there are a couple of different ways to export the data, and it's simply done by going to File. You can export the data in HYPACK's EDT format for the current line or for all the lines, and it'll put these files into the edit directory. Or you can export the data as XYZ, and I'm going to just export the data for this particular current line, and I'm going to export for all reflectors, depth, HYPACK, both. It pulls up this little dialog box which tells me all the corrections that I've applied to the data. It tells me I didn't have any layback corrections, no latency, but it tells me I've applied a sound velocity file and I've actually done tide correction. So if I export that, it's exported the data, and if I go to the sort directory, there is the data that I've exported, and if I go to the reference file, that is a little file which tells me all the corrections that I've applied to that data set, and then I can actually have a look at that data set as well. the X and Y coordinates, the depth to that reflector, and the HYPACK thickness. Right, one more thing I want to show you is if I'm happy with this interpretation here, I can actually output this file as an image file. So I can say save screenshot, and I'm going to put it in the screenshots directory, and I can choose to save it as a PNG, JPEG, or bitmap. I'll save it as a JPEG. Again, go and have a look at that file. Go to the screenshots directory. That's the screenshot that I've output. I can output it with the interpretation or without. And I've got a separate reference file here which gives me the start and end coordinates of that particular image file and its sweep length, which means that you can import this file as a vertical seismic curtain in third-party packages. Well, that is HYPACK Subbottom in a nutshell, and I'm going to hand back to Brittany.
Thank you, Peter. That was a great demonstration and presentation. We are so excited about this new and simple software solution and hope this gave everyone a better understanding on how HYPACK Subbottom profiling software works. Now, there were a lot of questions that came in, so let's go ahead and start the Q&A section of the webinar. We hope you stick around for this section, but if you're unable to, we want to thank you for joining us today, and we hope to connect with you in the near future about the HYPACK Subbottom software. So let's go ahead and answer some questions. We are going to try to get to all of them, but if yours goes unanswered, we will follow up with you via email over the next few days.
Brittany, we've got many questions that have come in, and I'll just read out the first one. Is can HYPACK Subbottom read and process Subbottom profiling data that was not collected in HYPACK? The answer is yes. We support most third-party SegWire datasets, and we can also read JSF files which are logged in EdgeTech Discover software. The next question that's come in is, does HYPACK Subbottom support the processing of large datasets? Again, the answer is yes. The single biggest dataset that I've pulled into HYPACK Subbottom is 20 gigabytes of SegWire data, and I was able to process this successfully. The next question I see on the list is, can HYPACK Subbottom log non-projected data in latitude and longitude? The answer to this is yes and no. HYPACK's geodesy currently doesn't support non-projected datasets, but within the SegWire file, the latitude and longitude is actually stored in the trace header, so you can actually use this in a non-projected format. I've got another question that's come in here. Can the system identify and highlight potential subsurface obstructions? Yes, subsurface obstructions might be a shallow rock surface or a buried pipeline, and yes, we can detect that quite easily, but it relies on the interpretation ability of the geophysicist or surveyor who's interpreting this data. Another question that's come in, which chirp equipment models can be used? If I go through the list now, currently we support all EdgeTech chirp systems, all Geoacoustics chirp systems, Knudsen, and there are possibly some more. Oh yes, we also support the Teledyne Chirp 3 and the older Benthos chirp systems. We're currently working on the driver at the moment for client's chirp system. This will be out fairly soon. Another question that's come in, during acquisition, are filters TVG applied to the raw data or just display? HYPACK never ever changes the raw data, so any of the filters that you've applied during acquisition TVG are never stored to the raw data. The only thing that is stored to the raw data are your settings either in your analog card or any base gain that you apply to the dataset. We never mess with raw data. Another question that's come in, can you export the processed pretty data to SegWire? No, you currently cannot do that, but what we do is we store all of the processing parameters in the XML file and the config file, so it's very easy for you to load up a raw SegWire dataset and actually apply those configuration files to it.
Okay, everyone. Unfortunately, we are out of time, so we're going to wrap this up We want to thank you all for your participation and hope you enjoyed the webinar today. Everyone will get a copy of this presentation, and we will get in touch with everyone who had unanswered questions over the next week. Also, please do not hesitate to contact us. We would like to hear from you. We can be reached at sales@hypack.com. And don't forget to check us out on HYPACK, Twitter, our Facebook and LinkedIn pages for upcoming news and events. Also, make sure to check out our Sounding Better newsletter on the HYPACK website to view Peter's articles on this new software. We hope to talk to you soon and have a great rest of the day.